In this problem, we are told we are working with an arithmetic sequence, and we want to model this sequence writing both an explicit and a recursive formula. Remember, for explicit formulas, we're going to have a of n equals the common difference times n minus 1 plus the first term. So once we can identify these two terms, it'll be pretty easy. The common difference, and we did this previously, is you're taking the second number minus the first. Remember, this is assuming that we've already been told this is an example of an arithmetic sequence. You don't have to prove it. So I have a common difference of 4, second minus the first, and the first number is 5. Now I'm going to distribute 4n minus 4 plus 5. Combine like terms, I have 4n plus 1. What is the purpose of this? This is an example of an explicit formula. This allows us to predict any number within this pattern. So first, second, third, fourth, right? These are the first, second, and third, fourth terms. Well, what if I said, hey, what is the 10th term? Well, instead of adding 4, adding 4, adding 4, adding 4, I can simply plug in 10. That's my input. 4 times 10 is 40. 40 plus 1 is 41. I can assume that the 10th term in the sequence is 41. We're going to come back to that thought in just a little bit. Let's do a recursive formula. So recursive formula, you need to identify the first term in the sequence, and then it's a sub n equals a sub n minus 1, and behind this represents the common difference. Because we are adding 4 consistently, it will be a plus 4. The last thing we're going to do here is we're going to talk about adding up. So what is the sum of a specific number of terms in the sequence? So here's the formula. Please write it down. And this will allow us to quickly add up. So let's say I want to know what's the first 10 terms added up. What is the sum of the first 10 terms? Well, the really slow way would be to go, okay, add 4 to this to get 21, add 4 to get 25, add 4 to get 29, add 4 to get 33, then 37. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then you add them up. And that's doable, and especially when you're working with integers. But when you get into fractions and decimals, it's not going to be pretty. So we're going to learn this quick way. This is also a formula that the ACT anticipates you have already memorized. What does this mean? So this represents how many terms, so the number of terms you're adding up, and it always starts from the beginning of the pattern. So when they say you're adding up the first 10, for instance, it's not just any random 10, it's the first 10 in the sequence. We're going to add up the first 10, so I'm going to replace the n with 10. A sub 1, just like we have over here, is the first term. A sub n means what is the last term. So I want to go the first 10 terms, so I do need to know what is the actual output for that last term. So I want to add up the first 10. The output for the last term is 41. And you're always going to divide it by 2. So I'm going to grab the calculator, and correct notation looks like this. I'm adding up the first 10 terms in this sequence. Here we go. So I'm going to take 5 plus 41, doing PEMDAS, doing the parentheses first. I'm going to divide it by 2 and take it times 10. And we can anticipate that if we added up the first 10, so if I did 5 plus 9 plus 13 all the way out to plus 41, it would equal, in this case, 230. Looking at another example that does involve decimals, we are told we can assume that this is an example of an arithmetic sequence. Again, that means we're either going up or down by consistently adding or subtracting, but the same number, same common difference. Your common difference is represented with a D. So let's figure out what that is. I'm going to take the second number, and I'm going to subtract it from the first number. And sometimes we do have confusion with negatives here. A negative sign is below the 3. A subtraction sign is next to the plus sign on the right-hand side. So second number, subtract first, and then what do we get? We get a negative 1.3. Now we can make sure we did that right by doing the following. I take that answer of negative 3.3. I'm going to subtract again. I'm going to subtract a negative 1.3. And we can, oops, sorry, here. I wrote it down. So I have a negative 3.3. And it's the same thing, by the way, as adding a negative. Whether you subtract 1.3, you'll see this, or if you take the negative 3.3 and you add a negative 1.3. Subtracting is the same as adding a negative. In both cases, we get the third term. So just showing you that it does work. I'm going to replace the d with a negative 1.3. You could put it in as a decimal if you prefer, and the first number is a negative 2. This is explicit. You do have to know the difference between explicit and recursive. So negative 1.3 and minus 1, minus 2, and now when I distribute, I get negative 1.3n. Two negatives make a positive, plus 1.3 minus 2. And you could plug this into the calculator for those that need so. Negative 1.3n. When you plug this in, you're going to end up here with a negative 0.7, but 1.3 minus 2, you can see the negative 0.7. I have not rounded any of the decimals. They are terminating decimals. This works. What does this allow us to do? It allows me to figure out what would be the 7th, the 6th, the 10th number, the 20th number in this sequence. I plug in 10, for instance. I do the math using PEMDAS. Whatever my output is represents that term, that number that corresponds to that term. How do we write down recursive? So the first number is negative 2. A sub n equals a sub n minus 1. This always refers to the number, the previous number. And then the common difference, again, is a negative 1.3. Recursive explicit. Okay, so if I told you I want you to add up the first 7 numbers, what does that look like? Adding up the first 7. Okay, so the number out front is your n. We want to add up the first 7. It's always your first number, and you're going to add to it what the last number is. Well, I need to know the 7th number, and then always divide it by 2. Again, this is the number you're adding up, so it's the first 7 numbers in this sequence. I'm taking the first number in the sequence plus the last number. Well, when they say last, I mean in this case the 7th. So I have 1, 2, 3, 4, 5, 6, 7. How can I figure out what the 7th term is? I can use this. Negative 1.3 times 7 minus 0.7. I want to make sure I plugged it in right. So what is the 7th term? It is negative 9.8. I'm not asking just for this final answer. I want to know when you add all of these up, what do you end up with? So in this position, it's negative 9.8. And now I'm going to let the calculator do the work. Negative 2 plus negative 9.8. I'm going to take it and divide it by 2. And lastly, multiply it by the number out front. We can assume that if we add up the first 7 numbers in this particular sequence, we'd end up with a negative 41.3. We are provided with a third arithmetic sequence that involves fractions. We are told this is an example of arithmetic sequence. I do want to show you, in case that is confusing to you, how you can figure that out. So we're looking for a common difference. I'm going to take the second number, 19 over 20. I'm going to subtract it from the first, 3 divided by 4. Remember, we're never going to round decimals. Okay, so I'm getting an answer of 0.2. Because it is positive, I'm going to assume we're going to add 0.2 each time. So here we go. I'm going to take the second one. I'm going to get an answer. I'm going to add 0.2. Now, I want to know, is this equivalent to this fraction? By hitting math on the calculator, it's on the left-hand side, and on the very bottom right, hitting enter twice. I'm like, oh, it works. Okay, let's add again 0.2. This worked by adding 0.2. Let's check again. So add 0.2. Is this equivalent to this fraction? Hitting math, fractions highlighted, press enter twice. I can see again, if you add 0.2, get to the final term. All right, so how do we write an explicit formula? Well, here is the common difference. So A of n equals the common difference. Now, can you write 0.2? Sure, as long as you don't round the decimal. Or if you want to write it as a fraction, for instance, maybe it's a multiple choice test and you don't see the decimal, hitting math and enter, 0.2 is equivalent to 1/5. So I have 1/5, n minus 1, and the first number is 3/4. Now I'm going to go through and I'm going to distribute to get 1/5 n, positive 1/5 times negative 1 minus 1/5 plus 3/4. And I'm using the calculator to combine these. I'm not going to find a common difference or a common denominator, so I'm going 1/5 in parentheses plus 3/4, and then I don't want to put it down as a decimal, although it's not wrong. I'm going to switch it back into a fraction by hitting math, enter, 19 over 20. How do I know that it's plus? Because my final answer is positive. This is an explicit formula. It allows me to figure out any term here in the list. If I want to know the sixth term, I enter in 6, and the output will be the actual numerical value up here. How do we write a recursive formula? It's the first term, and a sub n equals a sub n minus 1, representing the previous term. And then because I have a positive common difference, I could put plus 0.2, or more than likely you'll see it as a fraction. What if I asked you to add up the first 7 numbers, in this sequence? Well, I want to, so we did 7 last time. Let's do 8 this time. So the first number outside represents the number you want to add up. It's the first, starting with the first one, so the first 8. And it's always the first term, which in this case is 3/4. I need to figure out what is the actual 8th term, and then I will divide those by 2. So how do I figure out the 8th term? This is 1, 2, 3, 4, 5, 6, 7, and 8. How do I figure out this value? I can come back to explicit. I want to figure out the 8th term. So I'm going to take 1/5 times 8 and then add 19 over 20, making sure I plug everything in right. So my input is 8. Because it's the 8th term, my output is the answer. I'm going to put it back into a fraction. It is 51 over 20. 51 over 20, way over here. 51 over 20. So PEMDAS, first I'm going to do the top, divided by 2, and then I'm going to take it times 8. There's the top, divide it by the bottom, and take it times the 8 out front. We can assume if we add up the first 8 in this particular sequence, turn it back into a fraction, we'll end up with 66 over 5.